Hey guys, in this video I'm going to walk you through how to solve every single question in paper 3 of the 2023 Maths Sats. Okay, let's get started. Question 2, tick the number, and then in bold we've got 80,306. We've got a variety of numbers going down. It says tick 1, so only one of these numbers is 80,306. Now this is why I like to use separators. Every time I have 1,000, I'm going to be separating that with a separator. So if I had a digit, I'd have however many thousands there with a separator, and then my hundreds there. So my 306 would be here, 306, and 80,000 would be here, there's 80,000. So it's going to look like that. And then we can look down the side and find it, or you could go down each one. So our first one here we can see is 8,306. This separator separates our hundreds from our thousands. This one is 80,000, but it's no hundreds, it's 36. This one is 80,000 and then 306, that's the number that's the one we're looking for. It does say tick 1, so we've got our answer, but you might want to double check. This one is 800,000, so it's not that one. And this one, you can see there's 300,000 there. Our next separator tells us how many millions there are. So this is actually 80,300,006. I talk a lot about place value and how to identify the digits in my number place value ebook. Talks all about how you can read really large numbers very quickly, especially using these separators. You might think of them as commas. In numbers, we think of them as separators. So tick 1, I've got my answer there, 80,306. Question 3, Amina draws triangle ABC on a grid as shown. She then reflects the triangle in the y-axis. Draw the reflected triangle on the grid and use a ruler. So triangle A, B and C just means that if we were to draw from each, if we were to follow these letters, A, B, C, that's our triangle. The y-axis is the one that goes up, Y to the sky. So that means that is our mirror line. If you reflect it in the y-axis, all that means is that is our mirror line. And we're just going to draw the reflected triangle. So if I was to just draw this mirror line in a different colour so that it stands out, like so. We're using this as a mirror line. When we are reflecting, we are simply going to make sure that each vertices is the same distance from the mirror line on both sides. So if that's to that side, it's to that side. I'm going to use the laser pointer. So this one is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And our top one, A, is also going to be 5, isn't it? Because it's parallel with B. AB is parallel to the Y line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm just going to put a little mark there. My marks might not be very clear on the computer screen, but there are marks there, there and there. And then you're just going to use a ruler to join them up. Now, when your examiners are looking at your paper, they will be able to zoom in and they will be able to see if any vertices is slightly out. So, for example, this one is slightly out from that corner. It's quite difficult to do this on a computer, but you'll have a certain amount of leeway. So I think they'll let you off up to like 2 millimeters or 5 millimeters, depending on the mark scheme. But please do use a ruler and make sure that your points, each corner is really clearly lined up. You don't have like bits hanging off the edge. Okay, so that is it reflected. Question 4, write the next two numbers in this sequence. We have a sequence here. We have 1,780, 1,880, 1,980. If we have a look, what digit is changing each time? It's this hundreds digit, isn't it? Okay, so we've got 7, 8, 9. Now, 1,000, so it's going up by 100 each time also. We could think about this by going up by 100. Because if we just think about 7, 8, 9, then automatically you're going to think, oh, 10. And then that can be where we get a bit tripped up. So if we added 100 to 1,980, we could also, it's actually more helpful to think about this as 17, 18 and 19, because then I can think of the next one as 20 and then 80. Okay, it's actually 2,080, isn't it? 1,980 plus 100 is 2,080. But I think about how many hundreds I've got. I've got 1,700 here, 1,800 here, 1,900 here, 2,000. It's the same as 2,000. So my next one, I'm going to add on 100. It's just going to be, well, if I think about that as 20, or if I think about that as 0, my next one is going to be 21 or 100, 2,180. You can see in every single number that 80 stays the same. 80 stays the same. The only bit that changes is this. We've got 17, 18, 19, 20 and 21. Question 5. Circle the two decimals that round to the same whole number. Okay, so the same and whole number are important here. So what we could do is we could think about rounding each decimal to a whole number. So if we're rounding to a whole number, that means we're getting rid of the decimal. We could also have a little look and think, for example, well, 13 and 17 are definitely not going to round to the same whole number, are they? They're going to need to be two numbers that are pretty close together. So just by a bit of a guess, you could look and you could say, well, 15 and 16, they look quite close together. It's probably going to be those, but you might want to go through each just in case. But if I look at my 15.9, that's telling me that I've got to round up to the next whole number. If I look at my 16.3, 0.3 is telling me I've got to round down. Okay, so I can straight away see that these two work. So I would circle those two. If you wanted to be sure, you could go to each one. So 0.2 means that's going to get rounded down. 0.7 means that's going to get rounded up. 0.6 means that that's going to get rounded up. So you could try and round each number and then find the ones that are the same, but it says circle the two decimals. That means there's only two answers. So you're going to use a bit of a process of elimination first. Use a bit of common sense to see which two numbers are sort of fairly close. So for example, even though 13 and 14 are close together, I can see it's a low 13 number and it's a high 14 number. So that's why I didn't choose those two. But for accuracy, if you're not able to sort of eliminate them, just have a go at doing all of them and then you'll find the two that have the same whole number. Question 6, write the missing number to make the calculation correct. Now you can see that we have our number at the beginning next to an equal sign. All that means is that this number on the left hand side is the same value as these digits, these numbers on the right hand side. Okay, so it's the same as if you swapped it around and put that number at the end. Now what I can see is this is a place value question. So if you're unsure on place value, you can check out my number place value book. If I use my separators here, my first separator here tells me that this is how many hundreds there are. How many thousands there are, sorry. That's how many thousands there are. This bit here tells me how many hundreds there are. And then this bit tells me how many millions there are. Okay, so we've got ones, tens, hundreds, then we've got 1, 10, 100, thousands, and then we've got 1, 10, 100 millions. Okay, so we can see here 1 million. This is 1 million, and this is this bit. We can also see that we've already got 450. Together, that makes 450. And this is pointing to this bit here. So the bit that we are missing is this section here, this 300. That is what's missing. But it's not 300, it's 300,000. So we would write in 300,000. Okay, this is a simple partitioning. You're taking a big digit and you are partitioning it into its separate parts. We're looking at how many millions, how many thousands, how many hundreds, and how many tens. Question 7. Here is part of a number square. The other part of the square has been torn off. So you can see we've got number square and then we've got like a ripped off bit here. What number was in the bottom left corner of the number square? So it wants us to say what number went here. And we're going to have to use the clues of this square. Now we can see that if we look at what we know, we can see that going across, we have 1, 2, 3, 4, 5 squares going across. And we've only got 2 here, so we've got 3 missing. So we've got 1 missing there, 1 missing there, and 1 missing there. And then coming down, we've got 1, 2, 3, 4, 5, and we've only got 2 here, so we've also got 3 missing down the side. So we've got a square missing here, a square missing here, and a square missing here. Okay, and you might want to draw them in, don't have to, it doesn't matter how neat it is. You might want to roughly just draw in the missing squares. Okay, now let's have a look at what we know in the square. So I can see going across from left to right, I've got half, 1, 1.5, 2, 2.5. I've got 3, 3.5, 4, 4.5, 5. What that's telling me is that it's going across in halves. Okay, so in this direction, it is increasing by a half each time. So that gives me a clue, and that's actually enough to answer. But let's just have a look going down. Going down, if I look at this far corner here, 2.5, 5, 7.5, 10, 12.5. It's going down by 2.5. And if we look at the other parts as well, 2 plus 2.5 is 4.5, plus 2.5 is 7, plus 2.5 is 9.5. So it's going down by 2.5. So you could also calculate 2.5 from this number 3, because we are looking for the bottom left hand corner, we're looking for this bit. But I think that counting in halves is easier than counting in 2.5, but we need to remember that we're going backwards. So we've got 12.5, 12, 11.5, 11, 10.5. And we've also got, so this is 10.5, 10 and a half. Bear with me, because that does look like a 6. I'm drawing on a computer. Just make sure that you don't let your zeros look like a 6. If you also look elsewhere, look 2.5, 3. That does go half. That does count half from that end bit to there as well. So if we've got 10 there, 10.5 is going to be correct. So just remember to then write your answer in the answer box and just make sure that your zeros look like a 0 and not like a 6. Question 8, match each shape to the correct name. So we have 4 shapes coming down the side and we have 4 names to the right of them. If you do not know your irregular from your regulars, and if you don't know the names of shapes, you must learn this. It's really imperative that you know some common polygons, as well as different types of quadrilaterals and different types of triangles based on their properties. And regular and irregular is something you definitely need to know as well. There's lots of information on this in my geometry ebook. So if you're not sure, please do check that out. Okay, so first of all, I am going to look at the two that are the same, pentagon. Okay, I know that a pentagon is a 5-sided shape. And then I'm going to look at the other one. We've got 2 hexagons. I know that hexagon is a 6-sided shape. Okay, so if I look at my purple first, a regular pentagon, so the 2 5-sided shapes. So we just would count. So 1, 2, 3, 4, 5, that is a pentagon, and 1, 2, 3, 4, 5, that is a pentagon. And if I look at my hexagons, 1, 2, 3, 4, 5, 6, that's a hexagon, and 1, 2, 3, 4, 5, 6, that's a hexagon. So we just need to make sure that we get the regular and irregular part right now. If I look at my 2 hexagons, the 2 green, I can clearly see that this top one it looks more even. Okay, the sides are the same length and the angles are the same. This one down the bottom, I can see I've got a short side here and a long side here. That is irregular. Okay, so that is my irregular hexagon and that is my regular hexagon. Okay, if I look at my pentagons now, I can see this first shape up here. It's got a really long bottom. One looks like a house. The base is far longer than the sides, and the angles at the bottom, like these are both right angles down here. The angles are different. Okay, if the angles are different, it cannot be regular. So that is my irregular pentagon. And this one here, although you might not have a protractor to measure it, you definitely know the other one has got different angles. So this one is going to be your regular pentagon. So you're just using a bit of process of elimination. This one will have the sides the same length and the angles will be the same. So it is regular. Question 9. Jack says, I multiplied a whole number by 3. My answer was 32. Explain why Jack is not correct. So when we have an explanation question, you need to basically prove why someone is correct or incorrect. In this instance, we have to prove why Jack is not correct. So some important bits to note is he multiplied a whole number, so it can't be a decimal number, by 3, and my answer was 32. So what Jack was saying is that he had a mystery number, he times it by 3, and his answer was 32. Now, if we use a check calculation, we know we're using the 3 times tables. What multiplied by 3 makes 32? Is 32 in the 3 times table? Well, we know it's not, because 10 times 3 is 30 and 11 times 3 is 33. Therefore, the number cannot be a whole number. Okay, so we could say something along the lines of 32 is not a multiple of 3. Or we could say 10 times 3 is 30 and 11 times 3 is 33. So there isn't a whole number that multiplies by 3 to make 32. So I've just put that in a different colour. So 10 times 3 is 30, 11 times 3 is 33. So there isn't a whole number that can multiply by 3 to make 32. That's another one. But 32 is not a multiple of 3 is a good enough answer. Question 10. Write the missing square number to make this addition correct. Now, this question did cause a bit of controversy in the press because of the way it's worded. I'll talk you through how to solve it and then you will understand why. So first of all, we've got 8 squared plus something squared equals 73. Now, if you were doing BOD maths, we would always solve square numbers first. So first of all, let's just write down what 8 squared is. Well, 8 squared is 64. So we know that it's going to be 64 plus something equals 73. Now we can use subtraction. We can use the inverse to figure out what that missing bit is. So 73 take away 64 equals 9. So I know that this missing digit here needs to be 9. And 9 is a square number. Okay, this is the bit where it caused controversy because it says write the missing square number. The square number is 9. However, we can't put 9 there because 9 squared is 81. That would make that 8 squared. That would make that 64 plus 81 if we wrote 9 in. So although the missing value is 9, that's the missing square number, what we need to actually write is the square the number that's going to square to produce the square number 9. So what we need to write in here is 3, okay, because 3 squared makes that 9. Okay, we need 64 plus 9 equals 73. 64 is a square number, 9 is a square number. So it's not actually the square number that we're writing in, it's the number that is going to square to produce that number. So that's why this caused a bit of controversy. You would have got a mark for putting 3 squared in, and I think they were giving marks for 9 if you scribbled the square bit out. So if you had have written in 9 and then scribbled the squared out, then they would have given you a mark. So not really sure. That was a bit of a mess up in my opinion on the people who wrote the SATs papers. But yeah, do look out for things like this. Don't assume that everything is correct. Use your judgment. We know that if there is that squared symbol there, then we have to square the number that is next to it. So just have a little look at that, pause that, and just have a rewind if you need to watch that again. 9 is a square number, but because that little 2 is there, we need to make sure we write the number that's going to produce the 9 once it's squared, not write the number 9, because that would make it 81. Question 11. At the start of April, a shop had 15,000 games. The shop sold 7,918 games in April, 4,624 games in May. How many games did the shop have left at the end of May? Okay, so this is a simple subtraction. Now you could do just subtraction, or you could do addition and subtraction. So you could start off your 15,000, subtract 7,918, then subtract 4,624, or you could, what I would do is add these two up and then subtract that. So I would be doing 7,918, add 4,624. So what I'm doing is I'm finding how many games were sold in total in April and May. So 8 plus 4 is 12, 1 plus 2 plus 1 is 4, 9 plus 6 is 15, 7 plus 4 plus 1 is 12. So that's how many games were sold in the 2 months, and I'm going to label it here. 12,542 games were sold in total in April and May. Now I can deduct that from my 15,000. So if I do 15,000, make sure you use your squares. You put a digit in each square. It helps you to line everything up. So when we do this subtraction here, we're going to have to do a bit of exchanging. So I've got to come all the way over here. If you're not sure how to do this subtraction method, then you need to check out my number calculation ebook that talks through how to do the formal written method for addition, subtraction, division, multiplication. So this is definitely something you need to know. So 10 take away 2 is 8. 9 take away 4 is 5, 9 take away 5 is 4, 4 take away 2 is 2, and 1 take away 1 is 0. So the answer is 2,458 games left at the end of May. So the other way you could have done it is you could have done your 15,000 and subtract your 7,918 to get your answer. Okay, so you could subtract the games sold in April from your 15,000, take that answer and subtract the games sold in May from that answer. And you can see you have exactly the same answer. It's whichever thing you feel more efficient with. I personally would add up and then subtract. Question 12. This is a drawing of a cuboid. I'm going to get my pointer, and you need to tick the nets that could make the cuboid. So knowing what cubes and cuboid nets look like is something you do need to know in year 6, and there is things on this. There's lessons on cuboids and their nets, or 3D shapes and their nets in my SATS ebooks, the geometry ebooks. Okay, so check those out if you are not up to date with properties of shapes, because you need to know 2D shapes and 3D shapes as well, including the nets. So tick the nets that could make the cuboid. You're simply going to look down each one. You're going to think about, if you were to fold it up, would it make a cuboid? So I can see in this first one that wouldn't, because I could fold all these sides up, and then this could fold up the side, but this bit is actually would overlap, so not that one. This one, I can see that this part, this would fold up, that would go up the side, this would go over the top, and this would go to the side, so that one would work. This one here, I can see if I folded this side up and over, these two are going to overlap, so that won't work. And this one is very similar to that one, except for this bit won't overlap, so this will actually work. This will go up to the side, this will go on top of this will fold up at the back, and this will fold up the front. So we've got 2 that make cuboids, and it says tick the nets that could make the cuboid. So do make sure you tick the ones that do. Question 13, write the missing number to make this calculation correct. Now, anytime that you see an equal sign, all that is telling us is that this side is the same value as this side. Okay, that's all it's telling us. Now, it can be very tempting to look at this and start to do lots of complicated calculations. So, for example, you might find the answer to this, and then you might find the answer to this, then add them together, and then figure out how many lots of 754 go into that answer. However, if you look, this has got something, look at what's common here. We have got 754, 754, 754. Okay, so let's look at how many lots of 754 have we got. We've got 6 lots of 754 and 3 lots of 754. So if we've got 6 lots of the same number and 3 lots of the same number, altogether, how many lots have we got? We've got 9 lots. Look at the 6 and the 3, it's just the same as finding 9 lots. 6 lots of 754 add 3 lots of 754 is the same as 9 lots of 754. There is no need to do lots of long-winded calculation. You can do the calculation, you might find the answer, but you're going to then have to do some dividing of 754, so it's going to take a really long time. And for a 1-mark question, it's often looking for something quite simple, so it's looking for your understanding of the properties of number. Okay, so in this instance, if you've got the same number, 754, it's just knowing that 6 lots of that number and 3 lots of that number make 9 lots of that number. Question 14. Here are 5-digit cards, and we've got the numbers 1, 2, 3, 4, 5. Use 2 cards to make a fraction equivalent to 25%. Okay, so this bit, equivalent to 25%, is something you actually need to know. From year 4 or year 5, you need to know a fraction that is the same as 25%. 25% is simply a quarter. So if I know that 25% is a quarter, I'm just going to look at my digit cards, and can I make that? Yes, I can. There's a 1 and there's a 4. So 1 quarter is the same as 25%. And the next one says use 2 cards to make a fraction equivalent to 0.4. So I'm going to have to zoom down in a moment, but let's have a think about what fraction is equivalent to 0.4. So I'm just going to move this up a bit. I know that anytime I have a fraction, the first decimal is how many tenths there are. So I know that 0.4 is the same as 4 tenths. However, I don't have a 10 card. I do have a 4, but I don't have a 10. So I can't do 4 tenths. However, 4 tenths is a fraction equivalent to 0.4. What I'm going to have to do is find an equivalent fraction. So I could think about going bigger or smaller. Now, if I made 4 tenths bigger, it would be 8/20ths, for example. Well, I don't have any cards that are bigger than 5. So I'm going to have to make this smaller. So what about halving it? So 4 halved is 2 and 10 halved is 5. So 4 tenths and 2 fifths, they are the same fraction. They are equivalent. So if 4 tenths is equivalent to 0.4, then 2 fifths is also equivalent to 0.4. Let's just check if we have 2 and 5. Yes, we do. We have a 2 and we have a 5. So I know I found my answer. 2 fifths is the same as 4 tenths, which is equivalent to 0.4. So my final answer is 2 fifths. Question 15. Amina went to a concert one evening. It took her an hour and 20 minutes to get there from home. She arrived at 7:10. At what time did she leave home? That's the first part of this question. There is another part which I will zoom down to after we've done this. Now, when I am solving time problems, I always use a number line, because I'm going to draw a number line in here. We cannot use column, subtraction and addition for time because the units of time are in 60 minutes and it just doesn't work when you try and add it using column. Okay, it might work for the odd question, but then you'll have one it doesn't work for. So always just use a number line. So if I think of this as a timeline, it took her an hour and 20 minutes to get there from home. So I'm going to do this as my journey. So it took 1 hour, 20 minutes. Or I might even want to write that in minutes. So I could say that's the same as 80 minutes. And she got there at 7:10. So 7:10 is when she got there. At what time did she leave home? So we simply need to work backwards. Now I am going to use my 1 hour 20 minutes to work backwards because I think that's going to be easier than counting backwards 8 minutes. Because what I can do is I can count backwards. Let's take away 1 hour. If I take away 1 hour, I know that's going to be 6:10. And if I now take away the 20 minutes, and even if you're stuck on 20 minutes, you could take that away in 2 jumps of 10. So we could do 10 and 10. So if I took 10 minutes away, I'm going to write this down here, that would get me to 6 p.m. And then from 6 p.m, if I take another 10 minutes away, that is 5:50. Okay, it might be easier than trying to take 20 minutes away from 6. You can break bits down, chunk it up. So she left at 5:50. Now you can double check. I can put PM because it says she went to a concert one evening. Don't think it matters if you don't put AM or PM in. Well, if you put AM in, you'll get a mark wrong because it says evening, but I think you can just write 5:50 and not write anything. If you are going to write AM or PM in, make sure it's correct. So you could just double check 5:50 plus an hour and 20 minutes. 5:50 plus an hour is 6:50 plus 20 minutes. 6:50 plus 10 minutes is 6:50 plus 10 minutes is 7 p.m. plus another 10 minutes is 7:20. So that works. The second part of the question says the concert started at 7:20 and it finished at 9:05. How long did the concert last? Again, use my good old number line. So if I drew my number line and I pop in at the beginning, started at 7:20. ended at 9:05. How long did the concert last? Now we can just simply find the difference in between. So from 7:20, what I would do is I would go to 8 p.m. first. So 7:20 to 8 p.m. Well, that is 40 minutes. And I'm going to write M. From 8 o'clock, I could now go to 9 o'clock. And that is 1 hour. And then from 9 o'clock to 9:05 is 5 minutes. So we're just doing chunks in the middle, okay, just to make it easier. So I've got 7:20, 40 minutes to get to 8 p.m, an hour to get to 9 p.m, and then 5 minutes to get to 9:05. And now all I need to do is to add up all these times together. So I've got 1 hour, and then add the 2 minutes, 45 minutes. Now, if those minutes had have gone over 60, then I would have had to add it to the hours, okay? So if it had been 65 minutes, then that would have been another hour and 5 minutes. So just make sure that when you combine your minutes back together that you've accounted for over 60 minutes is actually an hour. Question 16. A box of 24 chocolate eggs has a mass of 870 grams. The empty box has a mass of 30 grams. What is the mass of one chocolate egg? Okay, so we've got lots of information here. We need to pick through the numbers we've been given and what calculation we're going to have to do, what operation we're going to have to choose to find the mass of one chocolate egg. So 24 chocolate eggs is 870 grams. So we could be tempted to think we're going to do 870 divided by 24. However, it also tells us that the empty box has a mass of 30 grams. So what that means is we need to deduct the weight of the box to find out what the weight of 24 eggs would be. So if we started out with the whole box was 870 grams. However, if we took the box away, take away 30, that gives us 840 grams. 840 is the eggs, that's the 24 eggs, okay? Because the box is 30 grams. So now we've got the total of the 24 eggs, we can divide it now. So we're going to take our 840 and divide that by 24 to get our answer. Now, depending on each year, the mark scheme changes, but in some instances, just writing that out, even without an answer, can get you a mark because you have shown you know what calculation you need to do. So even if you get the 840 divided by 24, it's possible you could get a mark, but it does change every year. What I'm saying is, if you look at this question, you think, I don't know how to do it, at the very least, write out the number sentence that you need to do. At the very least, just write out the calculation like that. Even if you need to come back to it at the end, go through the paper, finish all the questions you feel confident with, then come back to doing this. One, when you come back, you won't have to read it again. You've already written the calculation you need to do, but at least write that because you never know, you could pick up a mark. So now let's do the actual calculation. I'm actually going to zoom in a little bit. So 840 divided by 24. If you're not sure how to do long division, I have my numbers calculation SATS ebook has got all the calculations, but I also have a really useful short course on how to do long division. It's just 5 short lessons and you can learn how to do long division really easily, as well as some other division tricks. So do check that out if that's just the one skill that you are stuck on. So let's have a quick go. So 24, what I would do is I would write out my 24 times tables first. So I'm going to quickly jot those down. So I've quickly jotted down my 24 times table and now I can start to solve. So 24 doesn't go into 8. it goes into 84. If I look down my list here, it goes in 3 times. So 3 times. I prove it by writing down how many times. So 84 times 70. 84 take away 72 is 12. Bring the next digit down. And 24 into 120, we can see there, is 5 times. We just prove it, 0, so that should have been the takeaway there. So it goes in 35 times. The mass of 1 chocolate egg, therefore, is 35 grams. So just as I mentioned before, if I zoom back out, even if you wrote in the number sentence, just showing that you understood that you needed to deduct the weight of the box from the box of chocolate eggs, and then take that number and divide it by how many eggs there are. Even that by itself might have got you a mark, even if you didn't get the calculation correct. But like I said, if you're stuck on long division, if it's just that one calculation, check out my long division course, because it's really, really easy to follow, and you will literally get it in 5 sessions. Question 17. This rectangle is divided into 3 parts. So you can see we have a rectangle. There is a line that looks like it's down the middle with A. And then in the other section, we've got a corner cut off. We've got B and C. So 3 sections all shaded within 1 rectangle. Part A is half of the rectangle. Part B is 1/3 of the area of the rectangle. What fraction of the area of the rectangle is shaded? So the shaded parts are A and B. So it wants us to say what fraction A and B is of the rectangle. It almost doesn't even matter about part C. Okay, so we've got part A as a half and we've got part B as 1/3. If we want to know what A and B are together, what we're doing is we are just adding 1/2 and 1/3. So this is actually just a fraction question, and it's just represented in a different type of problem. So in the arithmetic paper, you'd have it written like this, 1/2 plus 1/3. But in a reasoning paper, you are expected to figure out the number sentences yourself. So all we're doing is we're adding part A 1/2 plus part B 1/3. Now to add 1/2 and 1/3, we can't add it yet because we have different denominators. So we simply need to change them to the same denominator. So we're going to find a common multiple of 2 and 3. So 2 and 3 both go into 6. So we change both our 1/2 and our 1/3 into fractions out of a 1/6. So my 1/2 is going to be 3/6 and my 1/3 is going to be 2/6. Okay, they are equivalent fractions. If you're not sure on equivalent fractions, that is definitely something you really need to know in year 6, and you'll 100% need to know it going forward to year 7, 8 and 9. So equivalent fractions, you'll find lessons on that in my fractions ebook. It is really, really important to know about fractions because fractions comes up a lot in the stats papers. So now that we have the same denominator, we are able to add. So that's going to be 6, and we add our numerators up, and that is 5. So we have 5/6 of the rectangle is shaded. Question 18. This table shows the total rainfall and sunshine each year at Heathrow Airport from 2010 to 2015. So we have our table here, and you've got the years down here from 2010 to 2015. We have the rainfall in millimetres down here next to each corresponding year. And then we have the sunshine in hours down here next to each corresponding year. Use this table to complete the graph. Use a ruler. It's very important that your lines are drawn straight. If they are not, you will not get the mark, even if you indicate the right height. Okay, let's have a look. Use the table to calculate the mean. So the first part of the question, is to use the table to complete the graph. So you can see here on our bar graph, you've got rainfall at Heathrow. Along the bottom, we've got the years, and it's asking for the rainfall part. Okay, so you do need to make sure that you check the right part of the graph. This is all part of the statistics part of the Year 6 National Curriculum. I do have an ebook on statistics, and it goes over how to read and interpret and draw line graphs and pie charts. And bar charts are part of statistics as well. Okay, so we've got all the years completed except for 2012. Just quickly check 2010 here. Look, rainfall, it says 521, and you can see here it's slightly higher than halfway between 400 and 600. 2011 is slightly less, and you can see here it is slightly less. So 2012 is 700. So this is a nice one because it's exactly halfway between 600 and 800. Okay, so it's going to be exactly halfway. What I'm going to do is I'm just going to zoom in. So just to look, 2012 is 700 millimeters. So 2012 we would need to draw as 700 millimeters. So we would need to make sure that we go halfway. The top of your bar needs to be about there. Okay, I'm just drawing this for reference. So you would draw your bar up to that line, up to that line, and across. Obviously it's a lot easier for you to do on paper with a ruler. Okay, so you're just going to make sure that you've drawn your bar with a ruler and that it goes halfway between your 600 and your 800. Now, as you have got a ruler, you could actually measure that gap and then plot your 700 line as halfway. And then you could come along here and then make sure that's measured up the correct height as well. So that's part one of the question. We've labelled 700 millimetres of rain for 2012. Let's have a look at the second part of the question. Use the table to calculate the mean hours of sunshine for Heathrow Airport from 2013 to 2015. So a couple of important bits of information here. We're calculating the mean. That is also one of the statistic learning objectives for Year 6. It's in my statistics ebook. If you don't know what the mean is, you need to do a lesson on that. Calculating the mean is a specific type of average. The other thing to take note of was only from 2013 to 2015, so don't do all the other years. So let's have a little look at 2013 to 2015. So we've got 2013 to 2015. These are the numbers we are working with. To calculate the mean average, we need to add these three numbers up, and then we need to divide them by 3. So let's take these 3 digits and we're going to add them up. So we've got 1452, 1669 and 1508. Those were the 3 those are the 3 sets of data for hours of sunshine from 2013 to 2015, and we are just simply going to add these up. Okay, so I'm not going to dwell on how to add. That should be something you know how to do. I'm just going to go through methods. So 2 and 9 is 11 plus 8 is 19. 5 and 6 is 11 plus 1 is 12. 4 and 6 is 10. 15, 16, and then we've got 4. So added up all together, we've got 4,629. To find the mean, we then need to divide that by how many numbers were in our set of data. So there was 3 numbers that we used. So that means we need to divide by 3. So 3 into 4 goes once with a remainder of 1. 3 into 16 goes 5 times with a remainder of 1. 3 into 12 goes 4 times. And 3 into 9 goes 3 times. So this is short division. We don't need to do the long division method when it's a divisor less than 12. This is short division. So our mean hours, now the mean hours will always be a number that is roughly in between those other 3 numbers. Okay, so you can see it's bigger than the smallest number and it's smaller than the biggest number, and that's what we're looking for. So the mean hours of sunshine is 1,543. If your answer was smaller than the smallest number or bigger than the biggest number, then you've done it wrong. You need to go back and have another go. So for this question, knowing how to do the mean is important, but also making sure you pick the right amount of years and you don't do all the data. That can be really easy to do as a mistake. Question 19. These are the prices of some vegetables in a shop. We've got mushrooms, £3.20 for 1 kilogram. And then we've got carrots, 60p for 1 kilogram. Just make sure you take note that this is in pounds, this is in pennies, they're both in kilograms. Okay, so when you're looking at units of measurement, always just check how the money's represented in pennies or pounds, and any measurements, what units are used. Now here, Layla buys 500 grams of mushrooms. So that's grams, not kilograms. Very important to take note of that anytime there are different units. And 1¼ kilogram of carrots. She pays with a £5 note. How much change does Layla get? Okay, so we need to work through this from the beginning. So we have the price of each thing, mushrooms and carrots, and then we know how much Layla buys. So let's work out how much she pays for, or how much it costs for each item she buys. She's buying 500 grams of mushrooms and it's £3.20 for a kilogram. So for this, you need to know that a kilogram is 1,000 grams and that 500 grams is half of a kilograms of mushroom. So she's going to pay half of that £3.20. So you might be able to do that in your head, or you might need to do a division. So I'm just going to use this space over on the corner just because on the computer it's easier. So you might do £3.20 divided by 2. And when you're dividing with decimals, you just put the decimal above it in the bus stop as well. 2 into 3 goes once. There's a remainder of 1. Make that a bit bigger. 2 into 12 goes 6 times. And 2 into 0 goes no times. So half of £3.20 is £1.60. You might also do £3.20. You might do half of £3 is £1.50. Half of 20p is 10p, add them together, it's £1.60. Okay, so I'm just going to write £1.60 and my pound sign. That's for my mushrooms, okay, £1.60. She buys 1¼ kilograms of carrot. Okay, so for 1 kilograms of carrot, it would be 60p. But what about the quarter? So we need to find a quarter of 60p. So we're just going to do 60 divided by 4. You could do it in a bus stop, or you could halve it again. I like to just halve and halve again, but we will do a bus stop method. So 4 into 6 goes once with a remainder of 2. And 4 into 20 goes 5 times. If we halve it and halve it again, half of 60 is 30, half of 30 is 15. So the quarter kilograms would have been 15p. So we've got 60p for the kilogram, and we've got 15p for the quarter kilogram. That makes 75p. Okay, so if I was to write that out, I need to make sure I write it in pounds as well. So that is £0 and that is 75p. Okay, so I've got how much her mushrooms cost and how much her carrots cost. She pays with a £5 note. How much change does Layla get? Well, before we do that, we need to figure out how much it costs. So I'm just going to zoom in. Okay, so we have got, if we add them up, 0 and 5 is 5, 6 and 7 is 13, and 1 and 1 is 2. So her items cost £2.35, but she pays with a £5 note. So we need to subtract £5. Now again, if I put my pound symbols in, and £5 is £5 and 0 pennies, and we're going to subtract our total of £2 and 35 pence. Okay, so when we're subtracting, remember, if you're not sure how to subtract, then you need to check out the calculations ebook. Remember, you can't do 0 take away 5. The amount of times I've seen here 0 take away 5 is 5 and 0 take away 3 is 3. We cannot take 5 away from 0. We need to go over here and we need to do some exchanging and borrowing. So we need to make sure we do this. Okay, 10 take away 5 is 5. 9 take away 3 is 6. And 4 take away 2 is 2. If you need to double check by adding £2.65 and £2.35 just to make sure it adds up to 5, then please do so. And you'll see that the pound symbol is written in there, so you do need to write it as pounds. And if you converted everything to pennies and you got 265 pennies, for example, make sure you put your answer back into pounds, because the answer box specifies that it wants it in pounds. So your answer is £2.65. Paper 3, question 20. The length of this rectangle is 6 centimetres. The width is W centimetres. Anytime we have a letter to replace a number, we are working with algebra. Again, we have this, not actual size. That means do not use a ruler to try and answer the question. You use the information. You use maths and information to work out the answer, not a ruler. Circle all the methods that can be used to work out the perimeter of the rectangle. Now it's got in bold all. That means that there are possibly more than one method. And it's also got perimeter in bold. That means don't confuse it with area, for example. Okay, so all and perimeter are in bold. So to work out the perimeter of a rectangle, we need to remember that the perimeter is the outside. Okay, so stuff on area and perimeter is in my measurement ebook, so be sure to check those out if this is something that you need a bit more support with. So if I want to find the perimeter, I need to add around the outside. And with a rectangle, I know that this is going to be the same as the bottom and this is going to be the same as the side. Okay, so we could do a process of elimination. So W times 6, no, we're not going to have anything that involves multiplying, because that would be area. W times 2 plus 12. Well, W times 2 we do have, because we have a W and a W. And then plus 12, we do have plus 12 because we've got a 6 and a 6 that we need to add. So we do need to add 2 W's and then the 2 6's. So W times 2 plus 12 does work. Now it says circle all the methods. So something very important is also just to make sure when we're reading the question that we follow the instructions. So it says circle ones that can be used. So I need to circle that to show that that is correct. 2 lots of W plus 6. Is that correct? Yes, it is, because, put my W back there. All it's saying is that we need 2 lots of W plus 6. I do need W plus 6, and we do need to double it because there are 2 lots of W's and there are 2 lots of 6. So that is correct. And then the next one says 6 plus W plus 6 plus W. This is also correct because we have got a 6 and a W and a 6 and a W. So that is also correct. So we have 3 methods here that can all be used to find the perimeter of the rectangle. And what we've done is we've just done a bit of eliminating as we're going through, just testing each one to see if we agree that it would find the perimeter. Paper 3, question 21. There are 25 classes in a school. Each class has 34 pupils. 62% of all the pupils play a sport after school. What number of pupils do not play a sport? Okay, so there are a few different bits of information here that we might need to underline, and also we need to pay special attention to the actual question, which is what number of pupils do not play a sport. It's quite important that we pay attention to that. Underline it, circle it, star it, whatever, but make sure that you answered that part of the question. So we've got 25 classes in school. Each class has 34 pupils. And then 62% of all the pupils play a sport after school. So the first bit we want to know is, what is all the pupils? Let's do that in a different colour. What is all the pupils? So we would find out what all the pupils are by multiplying the 25 classes by the 34 pupils. So the first thing we need to do is 25 by 34. I'm going to pop it over here because it's easier for me on my screen. Obviously you would write it just on your squares. So 25 times 34 is just a long multiplication. So 5 times 4 is 20, 2 times 4 is 8, plus the 2 is 10. Placeholder. 5 times 3 is 15, 2 times 3 is 6, plus 1 is 7, and then we add them up. If you are not too sure on long multiplication, then this is in my numbers calculation ebook. Okay, so 62% of all the pupils is 850. So 62% of 850 play a sport. What number of pupils do not play a sport? And we need to pay attention to this. It's what number of pupils do not play a sport, not what percentage of pupils do not play a sport. So there are a couple of different ways to do this, and I will tell you the way I would do it, which I think is the most efficient. Now you could find 62% of 850 and then subtract that to find the children who don't play a sport, or we could just find the percentage of the pupils that do not play a sport. So if 62% do play a sport, that means that 38% don't play a sport. So we could just find 38% of 850. So it's going to zoom in so that I can write a bit clearer. So 38% of 850. So calculating percentages is found in my ratio and proportion ebook if you are not sure how to do it. In this instance, I'm actually going to do 850 times by 38, and then I'm going to divide the answer by 100. So if I do the answer in a different colour, 0 times 8 is 0, 5 times 8 is 40, 8 times 8 is 64, plus the 4 is 68. I'm just going to make this a bit thinner and go to another colour just to keep it nice and clear. So we're now going to do placeholder. 0 times 3 is 0, 5 times 3 is 15, 8 times 3 is 24, plus 1 is 25. Okay, so we're just doing some simple long multiplication here, and then we are adding it all up. 0 plus 0 is 0, 0 plus 0 is 0, 8 plus 5 is 13, 6 plus 5 plus 1 is 12, and 2 plus 1 is 3. So 32,300 is 850 times 38, but 38% is the same as 0.38. Okay, and 0.38 is 38 divided by 100. So I need to divide, so that divided by 100 makes 0.38. So this answer divided by 100 will give me my actual answer. So to divide that by 100, each digit moves to the right 2 spaces. So it would be 323. 323. Now, another way you might look at it is, I know that 50% of 850 is 425. So I know the answer is going to be a fair bit lower than half. 38% is a fair bit lower than 50%. So I know it's definitely going to be less than 425. So I know I'm in the right ballpark there. And you could also do 40%, subtract 2%. You could do 30% plus 5% plus 3%. All of these different ways will get you to your answer, but it is all about finding out that you need to find 38% of 850. Like I said, you could have also found 62% of 850 and subtracted that. In fact, I could probably do that very quickly now. 62% I'm going to do as 50%, 10%, and 2%. So 50% is 425, 10% is 85, and then 2%, well, 1% would be 8.5, so 2% would be 17. I could add all those up, 5, 10, 17, 2, 10, 11, 12, 4 and 1 is 5, so 527 children played sport. And then if I did 850 subtract 527, I can't do 0 take away 7, so that becomes a 4. 10 take away 7 is 3, 4 take away 2 is 2, 8 take away 5 is 3. Look, I have the same answer. Paper 3, question 22. Megan uses these number machines to calculate how many diagonals different shapes have. And we have some various shapes down the side: triangle, quadrilateral, pentagon. It's labelled how many vertices they have. So vertices are the corners. If you're not sure what vertices are or what diagonals mean, then there are plenty of lessons on shapes and their properties in my geometry ebook. We divide that by 2, and that tells us how many diagonals there are in a shape. So we're using a formula, an algebraic formula, to calculate how many diagonals a shape has based on the number of vertices. Complete the number machine for the octagon. So for this, we need to know how many sides an octagon has. So an octagon has 8 sides. So if you don't know how many sides different shapes have, or how many vertices, they have, then you really need to check out the geometry ebook, and because you do need to know these common polygons, how many sides, vertices, parallel lines, all these kind of things, the angles, all that kind of stuff you need to know. Okay, so the next bit may not be as straightforward, but there is a pattern. You can see that from triangle it's 0, and then it's going up by 1. So quadrilateral is 1, pentagon is 2. Now you could either write out a 6 and 7 sided shape, and then you could put in, okay, well that's going to be times 3, that's going to be times 4, so that means that's times 5. Or you might spot the link between this and this. It's always 3 less. Always 3 less, so 5 is 3 less. Okay, so either way, there's a pattern there. If you spot the pattern, you just need to continue it. The third bit is always divided by 2. So that means that's going to be divided by 2. And now we just need to calculate. So we're going to do 8 times 5 is 40, and 40 divided by 2 is 20. And that's your final answer. If you look at the other ones, just to check, 3 times 0 is nothing, divided by 2 is nothing. 4 times 1 is 4, divided by 2 is 2. 5 times 2 is 10, divided by 2 is 5. So we're just following along, and the last box, the number of diagonals, is the answer to the formula. Question 23, write the missing decimals. Now decimals is in bold, so it does mean you need to write the decimal. Now let's have a look. In our table we've got A, we've got a value for A, and we've also got, so these are my values of A and these are my values of B. Now here it says A over B. Okay, so we're thinking about that as a fraction. So for example, in this first one, if we wrote A over B, it would be 1. So if we're just literally writing down what A is over B. Let me get my pen back. So A is 1 and B is 4. Bear with me, my pen keeps disappearing. So you can see I've just literally written A, which is 1, over B, which is 4. 1 over 4. 1 over 4 is a quarter. And if we change a quarter to a decimal, it's 0.25. Okay, so if we look at the next one, A over B, A is 3 and B is 20. What is that as a decimal? Now, hopefully you know that any decimal that is over any fraction over a 10, that how many tenths there are, that's the first digit after the decimal point. So 3/20ths, I'm just going to go over to the left now. 3/20ths is the same as if we use, we can't go down to 10. I was going to go down to a 10. We can't go down to a 10 because I can halve my 20, but I can't halve my 3. What I can do though is go up to 100. Okay, because if I know what anything is if I know what a fraction is out of a 10 or 100, I can figure what that is as a decimal. So 20 times what goes into 100? How many 20s go into 100? It's 5. Okay, so 5 lots of 20 go in 100. So we do the same to the top. Times it by 5. 3 times 5 is 15. So if it's 15 100ths, that means it is 0.15. That is 15 hundredths. If you are not so sure on fraction, decimal and percentage equivalents, that's what this is, converting fractions to decimals to percentages, then check out my fraction sats ebook because it has all lessons on how to convert from fractions to decimals to percentages using everything I've just showed you. So the next one is 5/8. So 5 at the top over 8. Okay, so this one is not as easy to change to a 10 or a 100. So what we do here is we divide. Okay, fractions are simply divisions. 5 over 8 means 5 divided by 8. I'm going to do this as a bus stop. Now this is also in my fractions ebook. So 5 divided by 8. Don't be tempted to put 5 on the outside because instinctively we think the smaller number's the divisor. This is 5 divided by 8. We're getting a decimal number, which means the number's going to be less than 0. So I'm going to put the answer in a different colour. So 8 doesn't go into 5, we know. So we're going to put a decimal here and a decimal here, a 0 here, and we didn't use that 5, did we? 8 didn't go into 5, we've put 0. So we still need to use it. We're going to carry it over like this. And now we've got 8 into 50. Now 8 goes into 50 6 times because 8 times 6 is 48. So I've got a remainder, so I'm going to put another 0 over here and put my remainder of 2 next to it. 8 into 20 goes 2 times. Now 8 into 20, 8 times 2 is 16. That means there's a remainder of 4. So I'm going to put another 0 here and put my remainder next to it. I'm going to extend my bus stop line. So like I say, there is lessons on this in my fractions ebook if you don't know how to divide using decimals. And 8 into 40 goes 5 times and then we're done. So, but that is our final answer. Final answer is 0.625. So this last one is actually a learning objective in the national curriculum by itself. It's associating a fraction with a division. Okay, so understanding how you can turn fractions into a division to find a decimal answer is a whole lesson in itself, and I have a whole lesson on that in my fractions ebook. If you're looking for some effective revision to help you with your maths SATs, then check out the Pocket Private Tutor Shop. I have SATs ebooks and I have revision courses. The SATs ebooks cover every single thing from the Year 6 national curriculum, so you can be sure that nothing will appear in the paper that you haven't learned. Each ebook comes with a video which you can watch on a laptop, on a tablet, on your phone. You can even cast it to your smart TV if you want to watch it big. I have worksheets to help you practice the skill, and included are past SATs question examples. That means when you're learning a new math skill, I also include how that has looked in an actual SATs paper before. I also have some revision courses, I have practice arithmetic tests, I have loads of stuff that's going to help you to absolutely smash your SATs. So check out the Pocket Private Tutor Shop and download the course that's going to help you now.